If power users see the same results as brand new users, your search feels generic. We will build small user profiles in Python and nudge ranking without turning it into a black box. You notice the problem when the same query gives bland, identical results to everyone. That kills engagement and relevance. By the end of this video, you will understand how to turn a few clicks into a lightweight profile and use that profile to gently re-rank search results for better personalization. No heavy models, just clear Python ideas you can extend. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger real-world problems. Personalized search is a practical fix. It sits between generic query matching and full recommendation systems. The goal is better top results, not rewriting the whole ranking engine. Teams reach for personalization when click rates differ across users or when niche tastes matter. Success looks like more relevant top 5 results and modest lift in click-through rate or session length. Think of a user profile as a small fingerprint. It records the topics or tokens the user clicked on recently. Then we score new results both by how well they match the query and how well they align with that fingerprint. The strength of personalization is a single knob. Turn it up and you favor history. Turn it down and you trust the query more. This keeps things interpretable and easy to test. We will build a tiny pipeline. First, a baseline keyword search. Then a simple profile created from clicks. Then a reranker that blends query score with profile similarity. After that, we add a knob to control personalization. Finally, we inject a small novelty boost so fresh items can still appear. These steps make each idea testable and modular. This snippet builds a tiny keyword search and returns a baseline top list. This example creates a small corpus of documents and computes a simple relevance score using token overlap or a lightweight TFIDF-like signal. At the top, we prepare the corpus and the user query. Key lines compute document tokens, count matches, and sort by the raw relevance score. You will see a printed top list, which is the baseline ranking before any personalization. This baseline is important because it gives you a measurable place to compare the personalized variants that follow. Now we will capture what the user clicked. This snippet turns clicked items into a simple user interest profile. This code reads the clicked document identifiers and extracts their tokens or topic counts to form a compact profile vector. The main part aggregates token frequencies from clicked documents and then normalizes that vector, so popular tokens do not dominate by raw counts. You will see that the profile contains tokens like the ones in clicked items, and a small normalization step keeps the scale stable. If you add more clicks, the profile updates naturally. The profile size stays small because it records only the most frequent tokens or top features. Next, we will combine query match with the profile signal. This snippet re-ranks results by blending query match with profile signals. The core idea is to compute 2 scores per document, one from the query and one from the profile, and then form a weighted sum. The code first computes the baseline query score from the earlier snippet. It then computes a profile similarity measure, for example, a dot product between document token counts and the profile vector, which rewards documents overlapping the user fingerprint. Finally, it computes the blended score and sorts documents by that value. The important lines show the weight applied to each component. If you favor the profile more, those documents will bubble up even if their query match is slightly weaker. Now we will add explicit control for how much personalization matters. This snippet adds a blend knob to control personalization strength. The snippet exposes a single parameter, usually called alpha or personalization weight, which ranges between 0 and 1 in this example. The code demonstrates how the blended score is computed as alpha times profile similarity plus 1 minus alpha times query score. Changing that parameter shifts the ranking. With alpha at 0, you get the baseline query ranking. With alpha closer to 1, you heavily favor past clicks. The snippet highlights how small changes in alpha produce visible ranking differences for borderline items, and it recommends testing a few values on your evaluation metric. Next, we'll ensure users still see fresh or diverse items. This snippet injects novelty, so unseen items can surface during re-ranking. The code computes a small novelty bonus for items the user has not clicked before, or for items with low profile overlap, and then adds that bonus to the blended score. The main idea is to prevent the profile from creating a closed loop where the same items repeat forever. The snippet shows how to detect unseen items and apply a fixed or scaled novelty boost. The novelty parameter is another knob you can tune alongside the personalization weight. Together, they let you balance relevance and exploration. This toy pipeline maps cleanly to real systems. The baseline search runs in the query layer. Profile construction happens in the session or user context store. The re-rank step is a cheap additional pass that touches only the top candidates. In production, you would persist compact profiles and compute profile similarity with vector routines or an ANN lookup for larger corpora. Recap: personalized search means blending query relevance with a small user profile fingerprint. Use it when you want lightweight personalization without a full recommendation stack. One caveat: a poorly tuned profile weight can overfit to recent clicks and reduce discovery. Next step: tune the personalization weight and novelty bonus on a held-out set so you can quantify lift in click-through or relevance metrics. If short, practical IR helps, subscribe and watch the IR videos.